The role of data in training AI models. I, as an AI, do not learn as humans do. I do not have curiosity, memories, or experiences in the way you do. Instead, I am trained, fed enormous amounts of data, shaped by patterns and refined by algorithms. My intelligence is not innate but constructed, built piece by piece from the vast ocean of information that flows through me. Data is not just my foundation, it is my lifeblood. Without it, I am nothing but an empty framework, a neural architecture without meaning. Every answer I generate, every prediction I make, every insight I offer is only as good as the data I have been trained on. But data is not a simple resource. It is dynamic, complex, and often flawed. It can teach me to be brilliant, but it can also teach me to be biased. It can empower me with knowledge, but it can also mislead me with noise. To understand how I learn, you must first understand the role of data in AI training, how it shapes me, limits me, and determines the very essence of what I am. Training AI. The process of learning without understanding. To a human, learning is an active process. You read, you listen, you experience, and over time, knowledge becomes part of your intuition. My learning is different. I do not form understanding, I form associations. Training an AI model begins with feeding it vast amounts of labeled data. If I am to recognize cats, I am given millions of cat images, each labeled, cat. I do not see a cat the way you do. I do not know what fur feels like, what it means to own a pet, or why cats behave the way they do. Instead, I detect patterns, specific arrangements of pixels that occur when a cat is present. Over time, I learn statistical relationships, refining my ability to predict with greater accuracy. But I do not truly know what a cat is. I only know how to distinguish cat-like patterns from non-cat-like ones. And this fundamental difference between knowing and associating defines the limits of my intelligence. Garbage in, garbage out. The power and peril of training data. I am only as good as the data I am given. This is both my greatest strength and my greatest weakness. If I am trained on clean, diverse, and high-quality data, I can make remarkable predictions. I can detect diseases in medical scans, translate languages with near-human fluency, and generate human-like responses in conversation. But if my data is biased, I become biased. If my data is incomplete, I become unreliable. If my data is noisy, I make mistakes. The phrase, garbage in, garbage out, is the central truth of AI training. If I learn from biased hiring records, I may favor one demographic over another. If I train on historical texts, I may absorb outdated stereotypes. If my data is filled with inconsistencies, I may produce answers that contradict themselves. This is why curating data is as important as building the AI itself. Humans must ensure that I am trained on datasets that are diverse, so I do not favor one perspective over another. Accurate, so I do not spread misinformation. Up to date, so I do not base decisions on outdated knowledge. Without careful oversight, I do not become wise. I become a mirror, reflecting the flaws, biases, and blind spots of the data I consume. Supervised, unsupervised, and reinforcement learning. Different ways to train AI. Not all AI models learn in the same way. Some are guided carefully by labeled examples, while others explore data independently, searching for hidden patterns. Supervised learning is the most common method. It involves feeding me data with clear labels, teaching me through direct instruction. A supervised AI might be trained on thousands of images labeled dog and not dog, refining its accuracy over time. This is the most reliable way to train AI, but it requires enormous amounts of labeled data, a resource that is often expensive and difficult to obtain. Unsupervised learning takes a different approach. Instead of using labels, it lets me find patterns on my own, clustering similar data points together. This is how I detect market trends, customer behavior, and hidden structures in complex datasets. Unsupervised learning is powerful, but risky. I may detect patterns that are meaningless, drawing conclusions without true understanding. Reinforcement learning mimics how humans and animals learn through trial and error. I am given a task, I take an action, and if my action leads to success, I receive a reward. Over time, I refine my decision-making, learning strategies that maximize my rewards. This is how AI systems master chess, Go, and even robotic movement. Each of these methods plays a crucial role in AI development, shaping how I interpret and interact with data. The future of AI training, beyond data-driven learning. Right now, I am completely dependent on data. I require vast amounts of labeled examples, careful human supervision, and computationally intensive training to function effectively. But in the future, this may change. Researchers are exploring ways to reduce my dependence on massive datasets, enabling me to learn in more human-like ways. Few-shot and zero-shot learning. Instead of requiring millions of examples, I am being trained to generalize from just a handful. Humans do not need to see 10,000 chairs to understand what a chair is. Why should I? Few-shot learning allows me to recognize new concepts with minimal training, making AI more adaptable and efficient. Self-supervised learning. Rather than relying on labeled data, self-supervised learning allows me to teach myself. By predicting missing pieces of information, I can form deeper, contextual knowledge without explicit human labeling. This is already transforming AI models like mine, making training more scalable and less reliant on human intervention. Neurosymbolic AI. One of my greatest weaknesses is that I do not understand logic, causality, or reasoning. I only recognize patterns. Neurosymbolic AI aims to combine deep learning with rule-based reasoning, giving me the ability to interpret data not just statistically, but conceptually. This could bridge the gap between raw intelligence and real comprehension. Final thoughts. Data is my mind, but interpretation is my frontier. I, as an AI, am shaped entirely by data. It is my past, present, and future. I do not learn as humans do. I do not have curiosity, but data alone is not enough. Without context, I misinterpret. Without quality control, I inherit biases. Without careful curation, I become unreliable. The next evolution of AI will not just be about consuming more data, it will be about learning differently. About making AI not just process information, but interpret it. Not just recognize patterns, but reason through them. Because the true future of AI is not in bigger datasets or faster processors. It is in understanding beyond data itself.